Hello students, in this lecture you will learn about the Michaelson-Morley experiment. Michaelson-Morley experiment was done somewhere in 1880. The main purpose of doing this experiment was to determine the existence of the ether. The result of this Michaelson-Morley experiment was the ether does not exist. Beside that, it gave rise to two more results. One of them was the velocity of the light in a given medium is absolute. It does not depend upon the frame of reference. This experiment was able to calculate the velocity with which Earth is rotating. This diagram shows the experimental setup of Michaelson-Morley experiment. It contains S, which is the source. It is a source of monochromatic light. So this source S will send a fine beam of a monochromatic light. Then it contains a plate which is a semi-transparent. That means it can reflect the light as well as it can refract the light. So light is incident at 45 degrees with this plate. So the angle of incidence, if you draw the normal here, the angle of incidence is 45 degrees. So angle of reflection will be also 45 degrees. So it will go along that PA. So at the point A, there is a mirror M1. There is also a mirror M2 here like this. Then there is a telescope here. Now this full apparatus can be rotated by 90 degrees. Now if this apparatus is rotated by 90 degrees, this S will come on the top, mirror M1 will come to the right, mirror M2 will go below, and telescope will come to the left. So in the experiment, the beam of light from S is incident at the point P at the angle 45 degrees. Now at the point P, the beam will get reflected perpendicular to its incidence and it will strike the mirror M1. Then from this point A, that is from the mirror M1, it will get reflected back along the same path and it will come to the point P. Then it will pass through that plate and then it will enter the telescope. Then the transmitted beam, see beside the rays, since it is semi-transparent, part of that will be reflected, part of that will be transmitted. This transmitted beam will pass along this path PB1, it will strike the mirror M2. Then from the point B, it will get reflected along the same path and then it will get reflected at the plate and it will enter the telescope. So these two rays, one which was reflected, other which was transmitted, they will pass to the telescope and it will produce the superposition, producing the interference pattern. So through the telescope, you will see the fringes, bright and dark, alternately arranged. Now when this experiment was done, somewhere in 1980, the scientists believed that there is a ether. Then velocity of the light is not absolute. That means the velocity of the light depends upon the frame of reference. So velocity does not remain same in all the frame. Now the apparatus, full apparatus is kept on the Earth and Earth is rotating with a speed of 36,000 meter per second. Now since Earth is rotating, so the full apparatus will also move with a speed of 36,000 meter per second. And in that case, what will happen is the apparatus will experience a ether wind in the opposite direction. Just like when you travel in the car, you feel the breeze, but actually the air is not moving. You feel the breeze because the car is moving. So same way here, because the earth is rotating, so the apparatus is moving, it will experience the ether wind with the velocity v in the opposite direction. Now let us consider first, so the ray which is transmitted. See, there are two rays here. The incident ray, incident at point P, then this is a reflected ray striking the mirror M1 and a transmitted beam striking the mirror M2. Now let us first consider a transmitted beam from P to B1. From P to B1, length is L. Then the light is traveling from P to B1. See, velocity of the light is C, is direction from P to B1. Whereas apparatus experience the ether wind of the velocity v in opposite direction. So resultant velocity of this light will be c minus v. So time taken by the light to travel from P to B, that is at the mirror M2, will be equal to distance by velocity. The velocity is distance by time. So time is distance by velocity. Distance is L. This P to B1 is L, and velocity here is, resultant velocity is c minus v. So it is L divided by c minus v. Then at the point B1, on the mirror M2, the light will be reflected back to the P. So the distance traveled will be L. But what happens is, the light is traveling from B to P, and ether wind is also from B to P. So velocity of the light is c, and velocity with which the ether wind is moving is v. Both are in same direction. So resultant velocity with which the light will move is c plus v. So time taken by light to travel from P to B to P is distance L divided by velocity c plus v. Now the total time taken to go from P to B1 and B1 to P is T, and that is you have to add this time taken to go from P to B and plus time taken to go from B to P. So L by C minus 1 plus L by C plus V. So L by C minus V plus L by C plus V. Then you take that L outside. So what will remain there? 1 by C minus V plus 1 by C plus V. Take LCM. Denominator becomes C plus V, C minus V, and that the C plus V will come here, numerator, C plus V, plus the C minus V will come here, C minus V, and this plus V and minus V cancels. So what we get is 2C, and that L is there, and C plus V into C minus V is C square minus V square. And then what we do is, we take the C in the denominator of the denominator. So what remains there is 2L divided by 1 by C into C square minus V square. So in the previous slide we had come up to this, T equal to 2L by 1 by C into C square minus V square. So next what we do is, we take the C square out. So C square by C is C. Since the C square is taken out, here what remains is 1, and here there is no C square, so you have to divide by C square, so it will become V square by C square. Then this 2L by C is written here. Then 1 by 1 minus V square by C square goes in the numerator as 1 minus V square by C square raised to minus 1. See, this plus 1, when you taken to the numerator, it becomes minus 1. Then we use here binomial theorem. See, binomial theorem is one expansion of 1 plus x raised to n. X should be very small as compared to 1. And here we find that this is 1 and this is x. This v square by c square is much less than 1 because v is very much less than c. The velocity of the c is 3 into 10 raised to 8 meter per second. The velocity v is 36,000. That means 3.6 into 10 raised to 4 meter per second. C is 3 into 10 raised to 8. So V is much smaller than C. So this term V square by C square is very small. So we can use the binomial theorem. Now in the binomial theorem, 1 plus x raised to n equal 1 plus nx plus higher terms are there. That power of x will be there. So that x is very small. So that value will become smaller and smaller, and afterwards we'll neglect it. So we don't write these terms. So here n is minus 1, and this 1 minus minus plus 1 plus v square by c square. Okay, and the higher terms are there. But these higher terms will neglect because they will be very small. The powers will come there. So what remains there is 2l by c 1 plus v square by c square. In previous two slides, we had considered this transmitted beam going from P to B1 and from B1 back to P, that is reflected by mirror M2. Now we'll consider the reflected beam. See this reflected beam, that is the ray going from P to A. Now what happens here is the apparatus is also moving because Earth is rotating. Apparatus is also moving with the velocity v. So what happens is the light coming from here, it will not strike at the point A. Since the apparatus is moving, this light will incident the mirror M1 at the point A dash and not at A. And that is because of the motion of the Earth. Then, since it is moving perpendicular to the velocity with which the apparatus is moving, that means perpendicular to the velocity of the ether wind, the ether wind will not change the velocity of this light because it's perpendicular. Since it's perpendicular, that ether wind velocity will not have component perpendicular to itself. So let us say that time taken to go from P to A dash is T1, and that is P A dash time is T1, and it is moving the velocity c. It is not affected by ether wind. So it will be c into T1. So P A dash equal to c into T1. Then this A dash, A dash. See, this apparatus is moving with the velocity v. So time taken to go from P to A1 by the ray, and the time taken by the mirror to go from A to A dash will be also same, T1. But the distance is A1. And apparatus is moving the velocity v. That is the velocity with which Earth is rotating. So A dash will be equal to v into d, velocity into time, v into T1. Then a total part P to A dash to P, that is a P A dash plus A dash P, but this both will be equal. See, this will get reflected from A dash, and again the apparatus is moving, so it will not get incident here, but somewhere here at the P dash on the mirror M2, and this length will be equal. So this P A dash equal to A dash P dash, that is 2P A dash. Then if you use this right angle triangle, this P A dash C, then we use a Pythagoras theorem. Square of the hypotenuse equals sum of the square of the side. Hypotenuse is P A dash, so square of P A dash. The sides are PC and CA dash. So P A dash square equal to PC square plus CA dash square. But this PC equal to A dash, and this CA dash is nothing but PA. You can see in the diagram. So you get it like this. Then we have shown earlier that PA dash is CT1, AA dash is VT1, and PA, this PA is nothing but the length L. There is a fixed length L. So you get that CT1 square plus VT1 square plus L square. Square this each term. So C square T1 square equal to V square T1 square plus L square. Then you bring this on the left hand side. So C square T1 square minus V square T1 square equal to L square. Then you can take the T1 square outside. What do you get? C square minus V square into T1 square equal to L square. Now in the next slide, we'll try to simplify this to find out what is T1. From the previous slide, we obtained that T1 square into C square minus V square is L square. So T1 square equal L square by C square minus V square. Then take the root on both the sides. So T1 equal to L divided by square root of C square minus V square. So that is the time T1. Then the total time taken by the ray to travel from the path P to A dash and A dash to P dash. So P A dash plus A dash P dash. But both are equal. Each one is T1. So total time is T dash and each one is T1. So it becomes 2T1. And we substitute here T1. So 2, T1 is L by root of C square minus V square. Then this C square we take out of the root sign. So what becomes C? So when it is taken out, inside what remains is 1. Since V square, there is no C square there. So we have to divide this by C square. So what you get is 2L divided by C root of 1 minus V square by C square. And we write this like this, 2L by C. And this is raised to half. Root means raised to half. We take it in the numerator, it becomes raised to minus half. Then use the binomial theorem that say this comes as the minus half. So minus and as plus. So plus half V square by C square and higher terms. So higher terms we are going to neglect. So we have not written it. And next, since V is much smaller than C, as I mentioned earlier, we neglect the higher terms. And what you get is T dash is 2L by C. And what remains inside is 1 plus half V square by C square. In the earlier slides, we had seen that time taken by reflected ray is T and time taken by transmitted ray is T and time taken by reflected ray was T dash. Now time difference between this transmitted ray and the reflected ray is T minus T dash. We written here as delta T. And this we had find the expression for T 2L by C 1 plus V square by C square minus and also T dash 2L by C 1 plus half V square by C square. This we already derived. Then this first term cancels because one is positive, other is negative. Then this what we get here is 2L by C, then V square by C minus half V square by C square. So V square by C square minus half V square by C square. 1 minus half is half and what is common is V square by C square. So what we get here is 2L by C into V square by 2C square. 2 and 2 cancels and what we get is L V square divided by C cube. So this is the time taken between the transmitted ray and the reflected ray to travel that telescope. The path difference between rays returning to a distance traveled in the time delta t is, see now distance, see this is the time, delta t is time, what is the distance traveled? Distance traveled, you multiply the velocity into that time, so c into delta t. C here and delta t is Lv square by c cube. So it is Lv square by c square. There is a distance. In terms of wavelength, you divide by lambda and then these are Lv square by lambda c square, so many wavelengths. So basically distance is Lv square by c square. Now in the earlier part we have seen that this transmitted beam is affected by the ether wind, whereas reflected ray is not affected by ether wind. The reason for that is the direction of velocity of light and the ether wind is opposite for the transmitted beam, whereas reflected beam, the direction of velocity of the light is perpendicular to the direction of the ether wind, so they will not get affected. Now next what is done is apparatus is rotated by 90 degrees. So what happens is S comes on the top, M1 comes like this to the right. So now this reflected beam will get affected by the ether wind and this M2 will go down, so it is perpendicular to the ether wind, so the transmitted beam will not get affected by the ether wind, and that the source will go on the top and telescope to the left. So in this case, the uh, transmitted, when it is rotated by 90 degrees, transmitted beam will not get affected by ether wind because it is perpendicular to the ether wind, and reflected ray will get affected by the ether wind because it is in a direction opposite to that of the ether wind. Hence, the path difference, now we can write directly, the path difference between the two rays becomes LV square by C square and minus LV square by C square. One for the reflected, other for the transmitted. This formula will just get reversed when it was in the earlier position. So the corresponding shift in the interference pattern. So interference pattern which is obtained, shift is the difference. LV square by C square minus LV square by C square equal minus and plus, so 2 LV square by C square. So now this shift in the interference pattern, in first position, then in the rotation by 90 degrees is 2 LV square by C square fringes. Michaelson-Morley, they calculate this value by substituting the value of L, value of V and velocity C, and they found that it will get, when it is rotated by this 90 degrees, the fringes will shift by 0.37 fringes, 0.37 fringes. So theoretically, from this formula, they calculate the shift in the interference pattern. How much interference pattern will get shifted? 0.37 fringes. But when the experimentally the fringes are obtained, they are found to be in the same position. Even if you rotate to 90 degrees, the position of the fringes does not change. That means there is no shift. Now see, the experimental result is actually the correct result. The theoretical result is wrong because you might have made some wrong assumption. See, what we do experimentally, if every setting, everything is correct, then it will give the correct result. But theory, what is obtained from theory, the theory itself may be wrong. So the value may not get a actual value. So here what happens is, the theory tells that there is a shift in the fringes, whereas experimentally there is no shift. So that means there is something wrong in the assumptions which is made in this experiment. And that assumption was that apparatus was affected by the ether wind. So here what happened, the shift remains same, the fringes remain same position. That means that what is called the ether wind is not present. That means ether is not present. So ether is not present. Okay. Now this is the main result in fact. So this experiment was done to prove that ether exists, but result was just opposite. They found that ether does not exist. And one more assumption made was the velocity of the light was relative to the frame of reference. So this, what we have done here, it also showed that the velocity of light remains same in all the frame of reference. It is absolute. So there is another result. And from this formula, they are also able to calculate the velocity of the Earth's rotation. The content of this slide I already explained. What was the expected result? That fringe width pattern should change the position. What was observed in experiment was no significant change, and this thing happened because a wrong assumption were made that the ether is present, then the velocity depends upon the frame of reference. So because of the wrong assumption, it gave that theory gave the wrong result. Now this Michaelson-Morley experiment was done somewhere in 1980, but they still had a doubt about the non-existence of the ether. So they went on improving the apparatus of the Michaelson-Morley and somewhere in 1987 they did the experiment, and it was finally accepted that something called as the ether does not exist, and velocity of the light is absolute. But still there's no other theory to explain this. So the they're still keeping with the Newtonian idea, the presence of the ether, then the non-absolute velocity of the light. So the scientists known as Lorentz and Fitzgerald, they give the hypothesis called as the Lorentz-Fitzgerald contraction hypothesis. So they still presumed that ether exists, and the velocity of the light is not absolute. So still they wanted to preserve the concept of absolute framework attached to the ether, and still explain the Michaelson-Morley result. They wanted to keep that ether as a frame of reference and also explain that the results of the Michaelson-Morley. So they put forward this hypothesis. The assumption of this is Earth and rays of the light travel relative to the absolute frame of reference attached to the ether. When the body moves through the ether with the velocity v, it contracts in the direction of motion, becomes shorter by a factor root of 1 minus v square by c square. And there is no contraction in the direction or perpendicular to the motion. And that the length is L naught root of 1 minus v square by c square, where L naught is the length when it is stationary. Now, there is no much significance of this Lorentz-Fitzgerald contraction hypothesis, but you should know what is the statement. But there is no much meaning in that, so I will not go into the detail of that. Michelson and Morley, in their experiment, they proved that ether does not exist, velocity of the light is absolute. Somewhere the conclusion was made in 1987. Somewhere in 1900, the Maxwell gave a theory of the electromagnetic waves, and there theoretically proved that the velocity of the light is absolute. Michelson-Morley experiment experimentally proved that velocity of the light is absolute, and this Maxwell's theory of electromagnetic wave proved that the velocity light is an electromagnetic wave and velocity of the light is absolute. It does not change the frames of reference. These two results were used by Einstein to give the theory of the relativity. So this theory, the first he gave what is called a special theory of relativity, which is true for the inertial frame of reference. Now this special theory of relativity is based on the Michelson-Morley experiment and the Maxwell's theory of the electromagnetic wave. Now he used them as a postulate. So these are the postulates of the special theory of relativity. The first postulate is principle of relativity. All laws of physics are invariant in all inertial frame of reference. See, Newtonian mechanics, Newtonian relativity, that is the Galilean transformation, we are saying that the laws in mechanics, they are invariant, whereas laws of electrodynamics are non-invariant. So now Einstein used this postulate, and afterward he proved that also, that the first postulate, principle of relativity, all laws of physics are invariant in all inertial frame of reference. See, all laws of physics, mechanics as well as electromagnetic theory, all the laws which are occurring in the mechanics, study of the motion, and also electromagnetic theory, because of that of the electromagnetic wave, they are invariant. That means their form remains same in all inertial frame of reference. Then second postulate was principle of constancy of velocity of the light. That velocity of the light is absolute. It does not change with the frame. So velocity of light in a free space is constant in all direction and in all inertial frame of the reference.